So in the class we are going to discuss problems in analytic function. First, what is meant by analytic function? The function is a complex variable and it is the single valued and differentiable function. Differentiable not only in the particular point and differentiable in the neighboring point also. Okay, fine. So one important necessary condition is there for the analytic function. That necessary condition is known as the Cauchy-Riemann equation or CR equation. The CR equation is that ux equal to vy and uy equal to minus vx. That thing you have to be verify whether the given variable or function, complex function, is that analytic or not. Problem. Check the analyticity of the following functions. Check the analyticity of the following functions. 1. W equal to z square, W equal to 1 by z, W equal to sin z, W equal to z power n, W equal to z bar. There are 5 problems we are going to do. First one, W equal to z square. What is z here? Z is x plus iy z equal to x plus iy, W equal to x plus iy whole square. So you can get this as x square minus y square plus 2y xy. So this can be written as u plus iv. This is x square minus y square plus I into 2xy first floor. So u equal to x square minus y square, v equal to 2xy. What we have to prove? To prove CR equations. To prove CR equations. So what are the CR equations here? Ux equal to vy, uy equal to minus vx. Is it not? So you have to find that 4 values: ux, 2x, uy, minus 2y, vx. Vx is 2y, vy is 2x. Is it not? So from this you can see that therefore ux equal to vy equal to 2x. See that ux and vy is 2x. Both are same. Second one. What is the second one? Uy equal to minus vx na. So uy equal to minus vx equal to 2y na. Is it not? So CR equations are satisfied. CR equations are satisfied. Therefore, W equal to Z square is an analytic function. So listen, to check the given function is the analytic, first you have to write that what is the function W equal to Z square, then substituting Z equal to X plus IY, then expanding that function. From that expanding function you will get that U and V separately. Then you have to find four values Ux, Uy, Vx, Vy. Then after finding that Ux, Uy, Vx, Vy, here you have to do very carefully the differentiation. Differentiation is important. If you are doing the differentiation properly, then easily you can verify the CR equation. So what is the CR equation here? Ux equal to Vy, Uy equal to minus Vx. Very simple problem. Okay. First one is W equal to Z square. Second problem is W equal to what is the second problem? 1 by Z. So W equal to 1 by Z is there. So where Z equal to what? X plus IY. Then W equal to 1 by X plus IY. Now how can we separate that real part and imaginary part? Multiple with the X minus IY by X minus IY. Then what you get here? X minus IY divided by X square plus Y square. So what is W? U plus IV. So therefore, separating that real and imaginary part, separating real part and imaginary part, real part and imaginary part we get U equal to X by X square plus Y square. What is V here? Minus Y by X square plus Y square. Is it not? Now we have to find four values, four differentiations, Ux, Uy, Vx, Vy. So first we have to take this as equation number 1, this is equation number 2. Differentiate 1 with respect to X and Y. If you are differentiate with respect to X and Y, what you get? Dou E by dou X, that means U suffix X. So that is U by V model, na? So denominator is X square plus Y square whole square. What is numerator? Keep it that X square plus Y square, and then differentiation of X is 1 minus, keep it X, differentiation of X square plus Y square is 2X. Then what do you get? Y square minus X square divided by X square plus Y square whole square. It is Ux. Similarly, what is Uy? What is Uy? Uy equal to same thing, X square plus Y square whole square in the denominator. In the numerator, you are differentiating with respect to Y, na? Keep it that X square plus Y square, but differentiation of X is what? 0 minus, keep it X here. Then differentiation of X square plus Y square is 2Y, na? So that is equal to 2xy minus is there, na? Minus in front, minus 2xy divided by X square plus Y square whole square. Okay, now differentiate 2 with respect to X and Y. Differentiate 2 with respect to X and Y. That means Vx. What is Vx here? How can we find Vx? Same u by v model, that is denominator is x square plus y square whole square, numerator is x square plus y square, and then differentiation of y is 0 minus, already minus is there, so minus minus plus y. If you are differentiate with respect to x, 2x, so that is equal to 2xy divided by x square plus y square whole square. Fine. Now last one, vy. Vy is denominator is x square plus y square whole square, but in front minus is there na, keep it minus outside, then keep it that x square plus y square, differentiation of y is 1 minus, keep it y, differentiation of x square plus y square is 2y, so we can write the 2y here, then what you get, already minus outside, here also one minus is there, so you will get that minus of y square minus x square. Now once again minus is there, so y square minus x square divided by x square plus y square whole square. Now we have to verify, what we have to verify? Verify ux equal to vy, uy equal to minus vx. So what is ux here? Ux is this one now, y square minus x square divided by x square plus y square whole square. But what is vy? Same na. So verify ux equal to vy. What is the value? Y square minus x square divided by x square plus y square whole square. Similarly, uy equal to minus vx. That means 2xy divided by x square plus y square whole square. So hence verified that CR equation. Hence verified CR equations. Therefore, W equal to 1 by Z. W equal to 1 by Z is an analytic function. Okay, that is the second problem. Third problem is, what is the third problem? W equal to sin Z. Third one is W equal to sin Z. So Z equal to what? X plus Iy. Substituting x plus Iy, already we have done that same problem on yesterday. What is u, what is v for this? U equal to sin x cos hy, v equal to cos x sin hy. Okay, fine. So now we have to find that four values: ux, uy, vx, vy. Okay. So what is ux now? Even you can take this as equation number 1. It is equation number 2. Differentiate 1 with respect to x and y. What you get? Ux equal to what? Differentiate with respect to x. So sin x is there, cos hy is constant na. Therefore sin x differentiation is cos x cos hy. Similarly, uy equal to, what is differentiation of cos hy? What is differentiation of cos hy? Listen, here you can write as note, what is cos hy formula? Cos hy e power y plus e power minus y divided by 2. Okay, what is differentiation? Differentiate on both sides. Differentiation of cos hy equal to e power y. Differentiation is e power y. E power minus y is minus of e power minus y divided by 2. That is equal to sin hy. So differentiation of cos hy is what? Sin hy. Therefore uy is equal to, what is uy? When you are differentiate with respect to y, sin x is constant. Write that sin x. Differentiation of cos hy is sin hy. Listen, many of them have done the mistake in the part. They have written as minus sin hy. Differentiation of cos x is minus sin x. Similarly, they are written cos hy differentiation is minus sin hy. It is wrong. Okay. So do carefully the differentiation uy. Now vx. Differentiate 2 with respect to x and y. Differentiate 2 with respect to x and y. Listen nicely. What is uy here? Sorry, vx. Vx equal to v equal to what? Cos x sin hy. Yeah. Then vx is minus sin x sin hy. Sin hy. Vy equal to cos x cos hy. Differentiation of sin hy is cos hy. Now listen. To verify CR equations. To verify CR equations. That is what we have to verify. Ux equal to Vy. What is Ux equal to Vy? Cos x cos hy. Similarly, Uy equal to minus Vx. That is equal to sin x sin hy. Therefore, CR equations verified. CR equations verified. Therefore, W equal to sin z is an analytic function. Okay, fine. So that is the third problem. Fourth problem is W equal to z power n. Fourth one. W equal to z power n. Listen, where n is the positive integer. Take n is the positive integer. See, we are not able to verify n equal to 1, n equal to 2, n equal to 3, n equal to 4 like that. Okay, even W equal to z square we can do that. W equal to z cube also we can do that. In case W equal to z power 6, z power 7 is there, we are not able to do that now. So at that time, what we will do is convert into polar form. Convert into polar form. Write the note. Write the note. CR equation in polar form. CR equation in polar form. So what is CR equation in Cartesian form? Listen, CR equation in Cartesian form is Ux equal to Vy, Uy equal to minus Vx. It is a Cartesian form. The same form in polar form is dou u by dou r equal to 1 by r dou v by dou theta. It is very important point. Please make note down this. Dou u by dou r equal to 1 by r dou v by dou theta. It is one thing. Second one is there, na? Second one. And dou v by dou r equal to minus 1 by r dou u by dou theta. So you have to remember two formula. One is for Cartesian, second one is for polar. Okay. Now listen. Here, what is given function? Given is W equal to Z power n. So Z equal to x plus iy is the Cartesian form. Whereas already I have given Z equal to what is polar form. Already I have given what is polar form. What is polar form? What is polar form? R into e power I theta, where x equal to r cos theta, y equal to r sin theta. Okay, fine. So W equal to Z power n, then we have to substitute r e power I theta whole power n. Then r power n e power I n theta. You know De Moivre's formula, e power I theta formula, e power I theta. The e power I theta formula, De Moivre's formula. E power I theta equal to cos theta. Many times I repeated the same thing. E power I theta equal to cos theta plus I sin theta. So similarly, e power I n theta. This is also you have studied in that +2 level. R power n into cos n theta plus I sin n theta. This formula is very, very important. De Moivre's formula. So e power I n theta equal to cos n theta plus I sin n theta. If n may be any number, then you can substitute here. Okay. In case e power I 2 theta is there, cos 2 theta plus I sin 2 theta. Like that, you can write. Now listen, multiply that r power n inside. R power n cos n theta plus I into r power n sin n theta. It is W. What is W? W is u plus IV, equating real part and imaginary part. Equating real part and imaginary part. We are equating that real part and imaginary part. You will get that u equal to r power n cos n theta, v equal to r power n sin n theta. So you take it u as equation number 1, v is equation number 2. So differentiating one with respect to r and theta. Differentiating one with respect to r and theta, we will get that dou u by dou r equal to n into r power n minus 1 cos n theta. Similarly, dou u by dou theta equal to, what is dou u by dou theta? R power n minus, we can write minus in front and then multiple with n sin n theta. Okay, but we need that 1 by r dou u by dou theta. Na? We need 1 by r dou u by dou theta. So what is 1 by r dou u by dou theta? equal to minus of r power n minus 1 n into sin n theta. Differentiating to with respect to r and theta. Differentiating to with respect to r and theta. That means we will get that dou v by dou r. What is dou v by dou r here? What is v here? R power n sin n theta. So what is dou v by dou r? N into r power n minus 1 sin n theta, and then dou v by dou theta. What is dou v by dou theta here? R power n into cos n theta. But we need that 1 by r, na? 1 by r dou v by dou theta equal to r power n minus 1 n into cos n theta. So therefore dou u by dou r equal to plus 1 by r dou v by dou theta equal to what? What is dou v by dou r? What is dou v by dou r here? Dou v by dou r n into r power n minus 1 cos n theta. So here also you can see that 1 by r dou v by dou theta is n into r power n minus 1 cos n theta. So n into r power n minus 1 cos n theta. So this one is verified. Second one is dou v by dou r. Dou v by dou r equal to minus 1 by r dou u by dou theta. So that is equal to what you get? N into r power n minus 1 sin n theta. So both of them are verified. Hence verified CR equations. Therefore W equal to Z power n is an analytic function if n is an positive integer. Okay, that condition is there. If n is the positive integer, then W equal to Z power n is an analytic function. So only one more problem is there. Last one. W equal to Z bar. What is our W equal to Z bar here? We know that Z equal to x plus iy, where Z bar equal to x minus iy. But W is u plus iv, na? U plus iv equal to x minus iy. U equal to x, v equal to minus y. So what is ux here? 1. Uy is 0. Vx is 0. Vy is minus 1. You can see here ux is not equal to ux is not equal to vy, na? Therefore CR equation not satisfied. Therefore W equal to Z bar is not an analytic function. So to prove that analytic function, the given function is the analytic function, First you have to expand the function, then you can separate the real part and imaginary part, then find the partial derivatives, then you can verify the CR equation, finally write the result whether it is an analytic function or not. Okay. Check the analyticity of W equal to e power z. Also find f dash of z. Also find f dash of z. So how to find this? Now listen. Here given that W equal to e power z, that can taken as f of z. Z equal to what? Z equal to x plus iy. Substituting z equal to x plus iy in the function, we will get that u plus iv equal to e power x plus iy. It can be written as e power x, e power iy. What is e power iy? Just now I written na e power I theta formula, cos theta plus I sin theta. What is e power iy? What is e power iy? So e power x into cos y plus I sin y. So what is u? E power x cos y, and v is e power x sin y. Yeah? So it is equation number 1, it is equation number 2. Differentiate 1 with respect to x and y. What do you get? Ux equal to e power x cos y uy come here, e power x cos y, uy is minus e power x sin y. Differentiate 2 with respect to x and y. Differentiate 2 with respect to x and y. Then what you get? Vx equal to e power x sin y, Vy equal to e power x cos y na. So therefore, so we have seen here ux equal to Vy equal to e power x cos y. Similarly, uy equal to minus Vx equal to e power x sin y. Hence verified CR equations. Therefore, W equal to e power z is an analytic. So compulsory one problem will come from this. Okay, fine. To find f dash of z. To find f dash of z. So f of z equal to u plus iv. F dash of z equal to either you can multiple with differentiate with respect to x or with respect to y. Anyone we can do. That is ux equal to ivx. F dash of z equal to ux plus ivx. So ux is what? E power x cos y plus I into Vx is e power x sin y. Taking that e power x outside, cos y plus I sin y, that is e power x e power iy, that is equal to e power x plus iy, that is equal to e power z. Same thing. Because differentiation of e power z is e power z1. We can check it for other function. Even you can check it for sin z or cos z. Come after. Okay, fine. Prove that the analytic function. Prove that an analytic function. Prove that an analytic function f of z with constant real part is constant. Actually, it is that MCQ problem, or sometimes it may become in state and prove like that. Prove that an analytic function f of z with constant real part is constant. With constant real part is constant. Okay. Write the proof for this. How can we write the proof is given f of z is an analytic function. Given f of z is an analytic function. So once f of z is an analytic function, it satisfies CR equations. Therefore, it satisfies CR equations. It satisfies CR equations. That means ux equal to vy and uy equal to minus vx. Is it not? Also given u is constant. Also given u is constant. U is a function of x comma y. Is it not? U of x comma y is constant. It is given u of x comma y is constant. Okay, fine. What is ux? What is uy? Why? Because it is the constant. Because it is the constant, if you are differentiate that, you will get that is equal to 0. Therefore, ux equal to uy equal to 0. So u is that independent of x and y. Is it not? U is the independent of x and y. Even you can write that u of x comma y. If you are differentiate with respect to x and y means if it is equal to 0 means then it is constant one. So it is independent of x and y. But it satisfies CR equation. Ux equal to Vy equal to 0. Uy equal to minus Vx equal to 0. Is it not? Therefore, Vx, Vy also equal to 0. Vx, Vy equal to 0. Is it not? Because it is satisfying the CR equation, Vx, Vy equal to 0. Integrate this. V of x comma y equal to constant. So, if you are taking u is the constant, v is also constant. Vice versa. In case if you are taking v is constant, in case if they are asking the question like, prove that the analytic function with the imaginary part is an constant. The analytic function with constant imaginary part is also the constant. Like that, if they are asking the same proof, taking that v as a constant, then you can prove u is a constant. Okay, reverse. Fine. So v is a constant now. What is w? Analytic function f of z equal to u plus iv. So u is the constant plus I into v is the constant. Therefore, fully it is the constant. Therefore, an analytic function, we can write here an analytic function with the constant real part, an analytic function with the constant real part, with the constant real part is constant. Similarly, an analytic function with the constant imaginary part, is constant. So any one of the problem will come, or it may come in the tensor. It is one important property of the analytic function. So what are the important problems in the analytic function? You have to check that given function is the analytic or not. Okay, that is the first one. Second one is this one. Next one is very, very important, harmonic function. Harmonic function. Any function, first you write the definition for that harmonic function. Any function which has continuous second order partial derivatives, continuous second order partial derivatives, and which satisfies the Laplace equation, is called harmonic function. Listen, what is meant by that Laplace equation? Laplace equation. We have studied in functions of several variables. Actually, a Laplace equation, that is a Laplace transform. It is not Laplace equation. Listen, the functions of several variables we have studied that dou square u by dou x square plus dou square u by dou y square equal to 0 is two-dimensional steady state heat equation. Two-dimensional steady state heat equation. Simply we can say it is del square u equal to 0. It is very important one. You will study in the third semester. The proof and everything, solution, everything we will study in the third semester. That transforms and boundary value problems. Okay, fine. So it is that second two-dimensional steady state heat equation. It is known as the Laplace equation. It is known as the Laplace equation. So any analytic function which is satisfying this equation dou square u by dou x square plus dou square u by dou y square equal to 0, then that function is known as the harmonic function. Okay, fine. Properties of analytic function. Properties of analytic function. Property 1. Both real and imaginary parts of an analytic function satisfies Laplace equation. Satisfies Laplace equation. This is one important property. Properties of analytic function. Proof is there. Okay, fine. Here, write the proof for this. Write the proof for this. Let f of z equal to u plus iv is an analytic function. Is an analytic function. Therefore, ux equal to vy and uy equal to minus vx. Ux equal to vy and uy equal to minus vx. That means dou u by dou x equal to dou v by dou y, which is equation number 1. Dou u by dou y equal to minus dou v by dou x. Now differentiate one with respect to x. Differentiate one with respect to x on both sides. Property without proof mention. There. Differentiate one with respect to x. So if you are differentiate one with respect to x, what you get? Dou square u by dou x square, which is equal to dou square v by dou x dou y. Is it not? Similarly, differentiate 2 with respect to y. Differentiate 2 with respect to y. What you get? Dou square u by dou y square, which is equal to minus dou square v by dou x dou y. Is it not? Now we can write this as minus of dou square u by dou y square equal to dou square v by dou x dou y. Now see this. Here also dou square v by dou x dou y is there. Here also dou square v by dou x dou y is there. Equating that both. Even you can take this is equation number 3. This is equation number 4. Equating 3 and 4. Equating 3 and 4. Then what do you get? Dou square v by dou x dou y equal to what? Dou square u by dou x square equal to minus of dou square u by dou y square. Is it not? All are equal. Now that is no need here. You can see that take it that minus to that side. Then we will get that dou square u by dou x square plus dou square u by dou y square equal to 0. So satisfies Laplace equation. It satisfies the Laplace equation. Similarly, differentiate 1. Already we have differentiate with respect to x. In case now we have to differentiate with respect to y. Differentiate 1 with respect to y. If you differentiate 1 with respect to y, then what you get? Differentiate 1 with respect to y. Differentiate 1 with respect to y. What you get? Dou square u by dou x dou y, which is equal to dou square v by dou y square. Similarly, differentiate 2 with respect to x. Listen, what is the first case? In the first case, we have differentiate with respect to x and y. Differentiate 1 with respect to x, differentiate 2 with respect to y. Now we are changing. Differentiate 1 with respect to y, differentiate 2 with respect to x. Then what you get? Differentiate 2 with respect to x means dou square u by dou x dou y, which is equal to minus dou square v by dou x square. Now you have taken this is 5 and 6. Equating 5 and 6. Equating 5 and 6. Then what you get? If you are equating 5 and 6, 5 is what? Dou square u by dou x dou y. Here also dou square u by dou x dou y. If you are equating this both, then we will get that dou square v by dou y square equal to minus dou square v by dou x square. Take it to that side. That implies dou square v by dou x square plus dou square v by dou y square equal to 0. So it is also satisfying that Laplace equation. It satisfies Laplace equation. So hence we proved that both real and imaginary part of the analytic function satisfies the Laplace equation. Therefore, both real and the imaginary part of the analytic function satisfies Laplace equation. Property 2, if f of z equal to u plus iv be an analytic function, if f of z equal to u plus iv be an analytic function, then the family of curves u of x comma y equal to c1, v of x comma y equal to c2, where c1 and c2 are constant, cut each other orthogonally. Cut each other orthogonally. That means, so cut each other orthogonally means, 90 degree. That means C1, that means slope of first one and slope of second two is equal to multiplication of slope 1 and multiplication of slope 2 equal to -1. It is the proof of cut orthogonally, na? Okay, fine. Now, or the same problem may be asked like this. The same problem may be asked like this. The real and imaginary parts, of the analytic function these two properties are very important. The real and imaginary part of the analytic function form an orthogonal system. So how can we prove this? First, thus given f of z equal to u plus iv is an analytic function. Therefore, it satisfies CR equation. Na? So what is CR equation here? Ux equal to Vy and Uy equal to minus Vx. Okay. So it's satisfying the CR equations. We can already have this property. Okay, fine. Now, here given that u of x comma y equal to c1, it is a constant. If u of x comma y equal to c1 is a constant, then du equal to 0. Du equal to 0. Listen, we have discussed one important result in that first semester, functions of several variable, total derivative. Total derivative. In the total derivative, if f is the implicit function, f of x comma y equal to 0, then df equal to dou f by dou x dx plus dou f by dou y dy. Then dy by dx equal to minus, it is one important property. It is one important property. The same property we are using here. Okay, du equal to 0 means then dou u by dou x into dx plus dou u by dou y dy equal to 0. So you have to remember the step. You have to remember only one step. When du equal to 0, dou u by dou x dx plus dou u by dou y dy equal to 0. Then dy by dx is what? Then dy by dx is what? Minus dou u by dou x divided by dou u by dou y. Is it not? Okay, fine. It is that you take it this as m1. Okay, first equation. This is you take that slope on m1, first equation. Similarly, also given that v of x comma y equal to c2, where c2 is what? Constant. If you are differentiating that, you will get the dv equal to 0. dv equal to 0. So dv equal to 0 can be written as dou v by dou x dx plus dou v by dou y dy equal to 0. Therefore, here also we will get the dy by dx. So what is dy by dx here? Minus dou v by dou x plus, divided by dou v by dou y. Now listen, it satisfies CR equation. Huh? It satisfies CR equation. Now listen, we can write this equation is, now listen, Vx equal to what? See this, Vx equal to minus uyn. Then we can write that minus dou u by minus plus dou u by dou y divided by second one ux equal to vy. Yeah? So what is vy here? Dou v by dou y, dou u by dou x, dou u by dou x. Therefore, once again we can write the dy by dx equal to dou u by dou y divided by dou u by dou x. You can take this as m2. It is equation number 2. Okay. What we have to prove? To prove both the curves cut orthogonally. Both the curves orthogonally means m1 into m2 equal to minus 1 you have to prove. What is m1 here? So therefore m1 into m2 equal to, what is m1 here? m1 is there, minus dou u by dou x, minus dou u by dou x divided by dou u by dou y. What is m2 here? Dou u by dou y divided by dou u by dou x. So hence proved that both the curves cut orthogonally. problem in harmonic. The remaining property I will discuss next. Okay. Find that harmonic conjugate. Find the harmonic conjugate of u equal to e power x cos y. Find the harmonic conjugate of u equal to e power x cos y. Listen, harmonic conjugate means if u is given, you have to find v. If v is given, you have to find u. That is known as a harmonic conjugate. U is given, you have to find v. If v is given, you have to find u. This type of problem will come. Okay, fine. Write the solution for this. Let u equal to e power x cos y. E power x cos y. Then dou e by dou x equal to e power x cos y. Dou e by dou y equal to minus e power x sin y. Then dou square u by dou x square equal to e power x cos y. Dou square u by dou y square equal to minus e power x cos y. Therefore, dou square u by dou x square plus dou square u by dou y square equal to 0. U is harmonic function. So first one is U is harmonic function. So what is given here? U equal to e power x cos y. First you are finding that first derivative, then you are finding the second derivative, then adding both, then you will get the dou square u by dou x square plus dou square u by dou y square equal to 0. So if it is satisfying the Laplace equation, then it is a harmonic function. Keep it your mobile phones in the back first. Given that it is an analytic function, therefore CR equations are, what are the CR equations? Ux equal to Vy and Uy equal to minus Vx. So dou V by dou Y equal to, which is equal to dou E by dou X, which is equal to what? E power x cos y 230. Then second one, dou V by dou X equal to minus dou E by dou Y equal to e power x sin y. Okay, fine. If we are integrating with respect to y, then what you get? Integrating with respect to y, first one, then what you get? v equal to integrate with respect to y e power x sin y plus some function f of x. You are integrating with respect to partially, na? So v equal to e power x sin y some f of x. Similarly, if you are integrate with respect to x, integrate with respect to x, v equal to e power x sin y plus some function of y. Is it not? So what is the common here? V equal to e power x sin y. Therefore, v equal to e power x sin y. It is an harmonic conjugate. But in general, you have to write, na? So f of x, f of y is there. F of x is constant, f of y is constant plus some constant. We can write. Prove that. So I have done many problems. At least only one problem you have to do. F of z equal to, prove that f of z equal to z cube is an analytic function. F of z equal to z cube is an analytic function. Z equal to x plus iy. Then f of z equal to x plus iy whole cube. Then yesterday we have done that, na? U plus iv x cube plus iy whole cube plus 3 x square iy plus 3x iy whole square. Then what is u? What is v? What is u? What is v here? Yesterday I have given, na? X cube. U is real part, na? X cube. What is the one more real part here? Minus 3xy square. Imaginary part v. 3xy square, huh? No. 3x square y minus, na? 3x square y minus y cube. Okay, fine. Then what is ux? It is equation number 1, equation number 2. Differentiate one with respect to x and y. Differentiate one with respect to x and y. Then what you get? What is ux here? 3x square minus 3y square. Okay. Uy? Okay. Differentiate 2 with respect to x and y. then Vx equal to 6xy, Vy equal to, so Ux equal to Vy and Uy equal to minus Vx. Therefore, CR equations are satisfied. CR equations are satisfied. Therefore, f of z equal to z cube is an analytic. Okay, fine.